We got a great show for you today. On Factor of the Future podcast, we have Antonio Backley. He is the founder of Inlyte Energy. Now, this is a California-based company which is established in 2021 that develops safe, cost-effective ion sodium batteries. The idea is for ultra-scale, commercial, and industrial energy storage. So not just the ones you pop into your video games and not. These are full-scale commercial batteries that are meant to run entire buildings. He launched his company in the support from an active fellowship in partnership with the Lawrence Berkeley National Lab. A PhD and a postdoc alums of the Stanford's Material Science and Energy Department in the Chueh group, which is known for its advanced battery materials and electrochemistry. He led research in high energy density electrolytes for flow batteries. Earlier, he was among the first employees at a venture-backed clean energy startup, C12 Energy. He holds a bachelor's degree from Harvard in chemistry and physics with a secondary field in computer science. Originally from Hawaii, he now lives in San Francisco Bay Area with his wife and 2 children. Now, Alexandria and I, we go back and forth with Antonio throughout it, just trying to get a glimpse of what the market looks like as far as energy, particularly in the case of what we're dealing with today. And Antonio goes into a lot about the way that his technology is changing the way batteries are made. A lot of user-friendly materials are being brought into it, making it more cost-effective and giving it also a more efficient footprint. One of the things that he wants to take this company is a possible replacement for diesel generations in places like hospitals or data centers. And he says it's a competitive advantage that we see. So we're going to go into that a little bit, and he's going to explain to us where the future is in some of the batteries technologies and the work that he's doing at Inlyte Energy. Enjoy.
Welcome to Factor of the Future, People-Powered Health. Podcast focused on trends shaping the future of manufacturing. I'm Alexandria Bjork, your host, here with A.W. Schultz. 2 thought leaders with a passion for people and manufacturing. Today and every episode, we are diving deep into the advancements, sustainable practices, and dynamic changes transforming how we produce everything.
And now welcome Alexandria Bjork and A.W. Schultz.
Antonio Backley, thank you for joining Factor of the Future. So today we're excited to have you as a founder of a company, as an inventor. We want to start with obviously your brilliant solution to leverage clean energy and completely reimagine how batteries are produced and leveraged across multiple sectors. So let's get into it. Why don't you share the problem you realized and how that led to where we are today?
Awesome. Good to be here, Alexandria, AW. I'll try not to take too long. You get me started talking about batteries. That's always a potential challenge. But I'll go back. I grew up in Hawaii. I think that's always given me the sense that our planet is an island that we have to protect. So I got really passionate about energy and climate change. And about over a decade, probably 13 years ago, what I saw was that, solar and wind were just coming down in cost tremendously every year, and they've continued to do that. So they're now the cheapest form of electricity we have to build. And we need a lot of electricity now for data centers, for the AI age, for electrification. I care a lot about the climate and clean energy, but even if, I know some people don't, even if you don't, we need a lot of electricity. We need to supply it domestically, and we need it to be cheap. And solar and wind provide that. But the problem is, you only get them when the sun shines and the wind blows. So, what I saw is we're going to need a lot of energy storage on the grid at utilities, across the electric grid. So I decided, I did this whole survey of how do you store electricity, because there's a lot of different ways to store it, from pumped hydro to even ideas for stacking blocks and putting them down. But it turns out batteries are a very cost-effective, modular, deployable way. So I went to Stanford. I spent 8 years as a student, a PhD and postdoc in material science engineering, studying batteries. And the question for me was, how do you make the optimal battery for storing energy on the grid? Because on the grid, you don't have the same constraints as in a vehicle. In a vehicle, what you care about is energy density, is range. So lithium-ion batteries have been developed for that. They're really great for that. It's going to be hard to beat lithium-ion in terms of energy density for vehicles. But on the grid, you don't need to have the most energy-dense battery. What you want is a really low-cost battery that's also safe, that also lasts a very long time, and has a high round-trip efficiency. So I really started at the periodic table, and where that took me was sodium metal. Sodium's super abundant. Sodium metal has been used in batteries for a long time. It's really high performance. And there's actually safe sodium metal batteries called a sodium metal chloride battery. So, that whole arc of my research kind of led me to this battery called a sodium metal chloride battery that I got really excited about. And what I realized is that this type of battery was invented in the 80s, actually invented for vehicles at that point before lithium-ion was around. But lithium-ion beat it for vehicles. So it's been this kind of niche battery technology. But it's proven safety, long lifetime, basically all the performance attributes. It's used as a premium UPS battery right now. A couple companies making it around the world, including Horian, one of our partners. And I realized actually we have this opportunity now, with the need for so much storage on the grid, to reinvent this technology to be optimally suited for grid storage. And what that means is a few different design changes, but one of the big ones that we've done at Inlyte Energy. So I founded the company 5 years ago, and what we've done is we've made a breakthrough in the use of iron instead of nickel cathode. So what that means, using iron in this type of battery unlocks this hugely lower cost point and domestic supply chains for this battery. So yeah, we're really excited. Getting a lot of interest from utilities, like Southern Company is going to be hosting our first utility scale demo. Actually, this summer, later this summer, is going to be commissioned, and from data centers, from commercial industrial customers across the grid spectrum. So that's a little bit about what we're doing.
Yeah. Man, Antonio,
Brilliant.
I think our wheels are running for Alexandria and I. But what makes this battery different than others? Because I know there's you go to the hospitals or schools, and they've got generators. Is this a replacement for a generator, or is this a replacement for a general use?
Yes, thank you. Yes, great. Yeah, great question. So iron sodium batteries. So it's a different architecture than lithium ion, and different than sodium ion. So people that may have heard of lithium ion batteries may have heard of sodium ion batteries, but iron sodium, it has a ceramic membrane. I could get into the whole design of it, but those features allow it to have very long lifetime, intrinsic safety, so it doesn't have the fire risk of lithium ion, just due to the materials in it. You crush the cell. I mean, you've seen this over 40 years. You break the cell, it doesn't catch on fire. And actually, you can have the modules. So we make very large cells, and they go into big modules that you picture the size of a 20-foot shipping container, and individual cells can break, and the modules can continue operating. So it's very low maintenance as well. And then there's the abundant materials that make it up. So it's really the constellation of factors that make it better. Now, it is a little heavier than lithium-ion batteries. So, you put it into a vehicle, it's not, and it doesn't scale down as well. You're not going to put this into a cell phone. It's not a battery you can make in very small cells. But for making very large cells for the grid, it's extremely well suited. A little bit heavier, but you can stack them because of the safety. You don't have that fire risk. You can stack them easily. And again, you don't have that maintenance need, so you don't have to go up and do cell balancing every year like you would with a lithium-ion battery. So,
what's cell balancing? I don't know what that means.
Yeah. So, okay.
Sorry,
trying
we're
to
going deep.
Yeah, no,
I'm new to this. We've had some. I'm learning a lot about batteries in the last year.
Yeah.
So go ahead.
Yeah.
Can I guess really quickly?
Yeah. Okay.
Go ahead.
Okay. So I know nothing about batteries, for the record. I actually, before we got onto this episode, I asked Antonio, I said, where does the power come from? And that may be a separate conversation for later. But if I was guessing on cell balancing, I would have to presume that there's certain amounts of, if it's sodium ion or lithium ion, there's a optimal balance in each cell that allows for correct storage and output. So my guess is that over time, those balances become not calibrated or not in alignment with optimal running. And they, need to be kind of take from cell 1 and put in cell 2. Is that sort of on the right track?
Yeah, you want to. It's definitely on the right track. Because if they get too out of balance, then eventually you end up driving one of the cells into extreme voltages, and then you could have the issue of a thermal runaway reaction of that cell. So you really don't want that to happen. And the problem with most batteries, thermal runaway, then you have a fire that starts.
Fire, yeah.
Okay.
So, and there's plenty. I mean, lithium-ion batteries have plenty of safety mechanisms to catch that to happen, but we still have fires. We just had a fire last week in the UK of containers of lithium-ion batteries that had been put on the grid about 8 or 9 years ago. So in most batteries, I was pausing because I was trying to figure out how to do this concisely, because this is again the risk with me. I'll go way too deep here.
I know. And we're elementary here.
Yeah.
At least
I think. I'll try, like most batteries. So you have your positive and your negative terminal, right? You have the two sides of the batteries that are reacting, but they're separated, and so you have that reaction happen electrochemically. So the electron goes through the circuit, and in most batteries, that separator is porous, and so you can have reactants cross over, and then you have basically some capacity loss over time. Even if you're not using it, it just kind of drains itself over time. And I think everyone's kind of experienced this. And that's intrinsic to the design of the battery, because you have this porous separator that can allow things to go through. In our battery, we have a ceramic membrane that's non-porous, that's completely non-porous, and the sodium ions go through it through the lattice. It's actually a superionic conductor of ions. In the academic world, and so that solid state battery, you could call our battery in the realm of solid state batteries, although there's some differences here in terminology. But solid state batteries have this non-porous separator, and that means that the cells you never have that crossover that drains the cells, because the problem with that crossover is each cell that happens at a different rate. And so that's how the cells get out of balance over time. But with ours, that just doesn't happen.
That's fantastic. So, very fascinating.
Balancing it, like what's the maintenance on it then? I mean,
I knew you were going to go maintenance.
Yeah, you knew I was going to go there.
Yeah,
that's where my background is. So I mean, is it something that anybody in the facility could do, or is you have to bring somebody in, or I don't.
So to be honest, I'm not too deep on the maintenance of lithium-ion batteries and how it's done. I know in the past it's required skilled engineers to come in to do the balancing like every year or something. I think, there's work to try to automate that, but you don't want it has to. There's some level of knowledge that's required to be able to do that.
Okay.
Yeah, well, especially with the risk of fire, right? So I'm thinking of it from a safety standpoint. If it's not properly executed, it seems like with the lithium ion specifically, you're running the risk of a fire. So you wouldn't want just somebody out of the factory who has no knowledge, experience, and sounds like some scientific understanding tinkering with the balancing of these, because then you're looking at a fire and it sounds more like an explosion because these things are so large. So that kind of gets into the difference. So your battery is a significantly lesser risk for fire, doesn't require the same level of annual skilled, maintenance and, all those types of things. One of the things we touched on before we got into this episode here, the recording anyway, was the supply chain aspect so not only is your battery different in its design and its chemical makeup and all these other things, but you mentioned the difference in the supply chain. I think everybody here who listens to our podcast is so aware of the geopolitical concerns, and the changes are seemingly happening faster than most of us can keep up with. And that poses a real risk for supply chain across the board. So tell us how you've kind of gone about addressing that challenge and concern in your company.
Yeah, thank you for asking this, because this is really important to us. So, we have, the whole vision of the company is we're making batteries that are the lowest cost from the most abundant materials in the crust, right? We're talking sodium is the fourth most abundant element in the crust. Iron is the fourth most, sodium is the sixth most. Lithium is like the 32nd or something. So, these can be found anywhere, and that's the vision. Is this is something that any country can make domestically and for very low cost? Because when we get into manufacturing more, it's also a simpler manufacturing process than lithium-ion batteries. Yeah, but now with the way the world is going, China, basically. 98%, something like that, of the LFP cells used in the grid last year came from China, right? They dominate each step of the supply chain for lithium-ion batteries. Now there's a growing supply chain in the U.S. And absolutely I support that. We got to build batteries domestically, but it just pales in comparison to the size of the Chinese supply chain and the cost structure and so. From when we started planning our manufacturing, we've been seeking, only non-FIAC, non-Chinese, and domestic supply chains. And so, from our first large-scale manufacturing, we'll be at least 70% domestic supply chain of all the raw ingredients, and we can easily get that to 100% very quickly. And this leverages existing supply chains. We're talking about iron powder. The reactants in our battery are iron powder and food grade table salt. So yeah, and then you have steel for the casing. You have some aluminum oxide, bromite for the ceramic membrane. There's different other components that you put in, but the bulk of that material is we're talking about iron and table salt. And we just announced a partnership with a U.S. Iron company, Irvin. That's something that we've been really developing is a domestic supply chain.
Oh, and Tony, my gosh, you guys are ahead of the curve, because my research tells me that the other minerals, rare earths, other critical minerals are, especially in the EVs, is going to be having a big impact. And the fact that you're using readily available is that's exciting. That's actually reassuring when I hear that.
Yeah, especially at the scale that it sounds like these batteries. I mean, a 20-foot shipping container. That's a lot of material that goes into that. Yeah. And there's obviously also a little bit of talk that I've heard. So I I work in an industry that's heavily dependent on, or a business that's heavily dependent on steel. And so I've had the experience of purchasing international steel versus domestic steel. And I'm excited to hopefully celebrate some of the steel manufacturing coming back to the US. But besides the point, you talked about the manufacturing process also being different than what's currently on the market or what maybe some of your competitors might be doing. So you've got a reimagined, set of components and actual battery design, a reimagined supply chain that can be pretty much brought domestically 100%. Now tell us about the manufacturing process, because you said that's also reimagined as well. So I'd love to hear kind of what the standard was and how your battery is different from that standard.
Yeah. Great question. So, I think it's worth talking about the architecture, just a little bit of a lithium-ion or a sodium-ion battery versus our batteries. So in a lithium-ion battery, you have to make these very thin electrodes, and it's because the lithium ions can't transport very far in the way this battery is designed. So you're literally making, you have these foils of the metal current collector, and then you're casting electrodes that are like a micron thick, so like the thickness of a human hair.
Yeah.
And that has to be extremely well controlled, because if you have irregularities there, again, that could lead to the cells eventually going into thermal runaway. So you have these roll-to-roll coating, and it's amazing what has been able to be accomplished here with high automation and very large factory sizes, most of them in China. But it's an extremely complex process that you have to do with extremely tight tolerances. And so, you have companies like Northvolt that sought to make lithium-ion manufacturing in Europe, that eventually went under because it couldn't get its yields high enough. And so that's a major risk there, is that it's a complex manufacturing. You require dry rooms, solvent handling, precision equipment that requires more energy, and just has this risk of not producing within spec. And our batteries, we make very large cells that we make a ceramic tube. So that's the membrane, is the separator I called it before. So there's this conventional ceramic processing. It's powder preparation, pressing, and then sintering of the ceramic. And we're actually talking to suppliers of ceramics in the U.S. If they can make the tubes for us, and they're excited to do that. So we could either do that in-house or have someone, a traditional ceramics company, make these ceramic tubes, and then it's just a matter of taking the iron and the table salt, mixing them together, pouring them into the tube. We don't have to make these tiny electrodes, and
Wow.
So that's why it ends up being a lot simpler, and also the materials handling is a lot easier. It's not sensitive to that air and moisture. And then there's welding steps, there's sealing steps. There's a number of steps in here, but when you count it all up, you do all the factory models, and we're about half of the energy production per gigawatt hour of battery. About half of the energy production is lithium ion. We're less than 1/10 of the water usage, and we're 3 to 4 times more capital efficient in terms of building those factories. So when we talk about having to build out a lot of factories in the U.S., this is a much better way to go.
Fantastic.
Yeah, that's...
So I have a question, I guess, about welding. So one of my friends is a welder, and actually my ex-boyfriend, he went through like this whole like reimagined life and self journey. He went from corporate America and like the Appalachian Trail and all this stuff. He also became a welder, and I understand it's very difficult. So are you seeing a shortage or an abundance of welders? Because one of the things AW and I talk a lot about is the skills gap, the workforce readiness for U.S. manufacturing. And so what I'm thinking is, do you have a lot of like advanced manufacturing positions that you're struggling to fill, or are you feeling pretty good? And how do you think about where you place your factories across the map of the US? So I guess that's a lot of questions I just threw at you.
Yeah, great questions. Okay, so on the welding front, so we have actually our pilot manufacturing facility right now is in the UK. It's actually a long story. I try to tell shortly. We're a US-based company. I started the company 5 years ago. We're based in California, but I met the people who invented this technology. They're in the UK. The long story short is we ended up joining forces, and Inlyte Energy acquired their company. Yeah, so that's really given us this huge boost, leg up in being able to develop this battery technology, because we have the world experts in this area, and they have this existing pilot manufacturing line near Derby in the Midlands in the UK. So it's a pretty, to be honest, it's a pretty manual 30,000 square foot production line. We do TIG welding there. It has been hard to find people with that experience. Yes. But we have trained our own people to do that, and now they can do it very well. So, so we've had to do kind of our own in-house training on that. But in the larger factories, we'll be doing laser welding with automated systems. So we won't need a lot of weld. We'll have to do, when we make individual cells to test something, we'll have to have somebody that can do hand welding. But generally, it's going to go towards laser welding. In general, in building the U.S., so we're looking at scaling up in the U.S. We're looking at a number of different sites across the country right now. But what we're looking for is, the usual things: electricity costs, labor costs, and rent of the facilities, and then logistics. Yeah. In terms of workforce, we generally we can train what we need in our factory. So that's not a big barrier to us about where we would go. Yeah.
Can I ask, where do you find yourself circling around as far as geographical areas?
Yeah, we've mostly been looking in the West since our headquarters are in California. But there are some interesting places around. I'll say right now we're pretty excited about New Mexico.
Wow.
Yeah. For a number of different reasons, but we're still evaluating different places.
That's cool. I did a warehouse kind of location profile project. So like I was looking at exactly those things, like what is the energy availability and cost, what is the labor market and availability, and all these things. And I was honestly thinking you were going to tell me that you were looking at Nevada because of the availability of electricity, the benefits for businesses, and some of those things. So New Mexico is interesting. Can you share what some of the attractive, kind of competitive advantages New Mexico brings to the table? I haven't heard that before.
Yeah, New Mexico, the state has been extremely welcoming. They really want to build, the future economy there, the future domestic manufacturing economy. So that from that perspective, it's been really great to work with them as we plan our facility and the timeline and all of that. From all of those main inputs I mentioned, electricity, labor costs, rent, it's very attractive. I think one of the issues is it is a smaller state. So, if we were starting to build like massive multiple factories at once, it'd be a little harder to fit in. But with our ramp, it's actually really well suited for us.
Oh.
Yeah, we've had other guests on the show, and they really brought us to light on some of the energy shortages, particularly up north. And that's kind of what I was alluding to is, are you looking up north or down south? And it sounds like down down south is the most prosperous area going right now, and these are things that are coming to light for myself, and I think for our viewers too. As far as where people are, or where organizations are pulling toward. So yeah.
Okay, so I think we've covered a wide range of topics. Antonio, this has been such an awesome and out of my typical comfort zone and conversation, but I really, for that reason, fast and really enjoyed it, and I hope everybody else does too. Is there anything that you didn't get to share during this episode that you're kind of left, that you'd want to share now?
Yeah, no, it's been great. I'll just go back to that question about the use cases and diesel backup, because this is something that I think I was starting to answer it in one direction that got too long, but it's actually really exciting to us because what we've found out over the last year is that our batteries are actually, the whole idea when I got excited about this technology is it's something that's both very low cost and high performance across the board. And it turns out if you're trying to replace diesel as a backup at a facility like a hospital or like a data center, because there's a ton of data centers being built, and diesel now is becoming a limit in terms of local emissions, in terms of community pushback, and that's the standard for backing up these data centers. We actually have a data center in Switzerland. We're going to do a pilot. Our first pilot at a data center will be in terms of a diesel replacement, and that's planned to be commissioned by the end of this year. And so we're seeing a lot of interest here. And what our batteries can uniquely do is have be competitive, cost competitive with diesel, and also footprint competitive, which is really hard for batteries to do. But basically, even though we're a little heavier than lithium-ion needs a lot of spacing between it because you have this risk of a fire. And if you have a fire at one cell, you don't want that to propagate. And if it's in one container, you don't want that to propagate. So the standard is you have to put spacing between them. And so that makes it hard to fit that much that you need into that footprint of a diesel. With our batteries, you don't have that, so you can really pack it in, and then what you create is something that's, and there's other technical things about it. Like our batteries are really happy to stay at 100% charge and just stay there. Like there's no degradation of the batteries that occurs due to the ceramic membrane, and that's what you want in a backup. You want it to be ready to go at any time. Lithium-ion doesn't like to be set at 100%. That's going to degrade capacity. So there's multiple reasons that turns out we're a really good solution here, and it's really exciting.
That's really cool.
Yeah.
AW, do you have any closing thoughts, comments, questions, or are we ready to wrap it up?
I think we're ready to wrap it up. And Antonio, thanks for getting on the show and giving us a school on batteries. And I think I'm still at elementary level. Alexander might be moving up above me.
Is that a pun? Is that a pun?
No.
Ooh, periodic table of the elements.
The more I read about minerals, the more I read about batteries. It's just it's the next evolution of what we're seeing out there. So, I want to thank you for being on the show, Alexander. Great questions.
Thanks.
And stay tuned.
Yeah, thanks for being on the show. Great stuff that you're doing for clean energy and the environment too.
Thank you.
This is Factory of the Future, and we are out of here like finished goods. Stay tuned for our next episode of Factory of the Future, where we're exploring groundbreaking techniques and behaviors that are reshaping industrial landscapes. Don't forget to subscribe and leave us a review and help others discover the cutting-edge insights transforming manufacturing as we know it.